So, do you guys agree with me with this statement? Okay. Now, one of the things that we come up with, the reason why I showed this is because is 10 bigger than 3?
Yes.
Is 10 bigger than 7?
Yes.
Okay. What I'm getting at here is the idea that the sum of something is always greater than its parts. I think you've probably heard something along those lines before, right? The sum of something, no, I wouldn't imagine. So the reason why I want to talk about this is because as we get into triangles, what is angle 3?
1 and 2.
Right. Well, what is that called? You're right. It's exterior, yeah. It's an exterior angle, okay? It's an exterior angle. That's what she was saying. It was outside, right? It's outside. Now, remember, the angle that's on the outside is equal to the sum of the two it doesn't touch. Remember that, right?
Yeah.
Now, the reason why I want to bring that up is because we can actually say that exterior angle will always be larger than either of the two it doesn't touch. An exterior angle will always really, come on, be greater than either an exterior angle will always be greater than, it'll always measure greater than either of the two angles it doesn't touch. Again, this is one of those things that this section is more of like, well, duh. It kind of has to happen like that. So there's a few of those duh moments in this section. Actually, in these next two sections, believe it or not. This is more logic than it is math, if that makes sense. It's not that we're just purely just dealing with the straight logic problems or anything like that. We're still dealing with we'll still have some algebra and things like that as well. So, excuse me. An exterior angle will always be greater than either of the two angles it does not touch. So that means angle 3 has to be bigger than angle 1. It has to be bigger than angle 2 because the two of them put together make up an angle. Okay. Hopefully that's not too awful. Start off. Now it's real tough. You know, I can, but I think it'd be a waste of your time. The reason why we talk about these is because of this. Ooh, yeah, triangles. Oh, wait, no. Sorry, let me make that 80. Which of those would be the biggest angle? 80 degrees. Okay. Now, if you guys just take your hands, this would be 90 degrees, right? 80 degrees is a smidge less than that. What 40 degrees look like? Half of that. Good. All right. Now, what I want you to think of, then 60 is a little bit more. Now, think about the differences in the angles that you're making with your hands. Here's about 80 degrees. Look how far apart your fingers are. What happens when you go to 40 degrees? What happens when it goes to 60? It gets further away, doesn't it? So basically what that's getting at or what that gets to is the fact that you've heard this before. The bigger the angle, the longer the side across from it is. So it's kind of one of those things that you kind of makes sense that it has to be like that. The larger the angle, the longer the side length across from it is. That will always, always, always work. Okay. So which of those side lengths is the longest? The long across from 80, but in the labeling we call it side BC. So the longest would be BC. What's next? What? All right, I'm going to go from the longest to shortest. What would be the next? The next one would be the BA. And then lastly, the shortest one. Now, what we did there was something called a descending order. Bless you. You guys remember the difference between descending and ascending?
Yeah.
Sometimes they ask for us. Usually it's ascending order, but sometimes they'll throw in a descending order in there as well, just so you guys are aware. It's nothing more than the larger the angle, the longer the side would have to be across from it in order to create a triangle. Okay? And it works going the other direction as well. It works going the other way if you have side lengths that are longer. That means the angle across from them are bigger. Okay? So it works the exact same way if this was, excuse me, 12, excuse me, this one would be, I don't know, 7, and we'll say this one is 8, just for fun. It works the exact same way, that the longer the side length, the larger the angle is across from it. Now, those side lengths may not be true, but the idea is for where they go from there. You're going to be given angles or sides, put them in order, find the smallest segment, that kind of stuff. It's pretty darn simple. One of the things we will do as we get into second semester, once we get through working with Pythagorean theorem again, and some of the basic trigonometry stuff that we do, we're actually going to be able to figure out side lengths. We're at 8, 12, and 7. We'll be able to actually figure out the angle measures themselves that create that kind of a triangle. Basically, it's a lot of calculator work, but there's formulas and stuff to be able to do things like that. And we'll get there. It's called the law of cosines. Good times. Excuse me. Still fighting this stupid cold. All right, put them in ascending order. Ascending order, please. Side lengths in ascending order. Probably don't need to. If you'd like. Remember, ascending order means the smallest to largest. All right, what's the order? Which one's the smallest? LM? Is that the shortest one? LM? Shortest. Yeah, the shortest one up here has to be L, M, leopard, mule. The next one would be the monkey, Nebraska. And then the longest side length would be Leopard, Nebraska. Lima. No, is it November? What was M? I forget. M. Huh? Michael. Yeah.
What?
What's that?
Why am I so hard?
You don't like me?
Oh.
All right. Which one is the largest angle? So I'm also saying angle, not segment. So where is the largest? You can use one letter because it's a triangle here. B. Then the next largest would be, and then the smallest one would be. Okay, that was tough. Good luck. Okay. Now, this is the really easy part. The next part is where things get a little bit weird. Basically, what happens is the following. I don't want this is too many words. How many sides are in a triangle? 3. Okay. So what happens here is two sides. The sum. What does sum mean in math again? Adding. Of two sides in a triangle must be greater than the third. The sum of two sides in a triangle must be greater than the third. If that doesn't happen, you can't make a triangle with those side lengths. So the sum of two sides must always be larger than the third. Otherwise, it won't fold and create a triangle. For example, what's 7 plus 8?
15.
Come on. It's 15. Is 15 bigger than 12?
Yeah.
All right. What's 8 plus 12? It is like 20. Very good. Is 20 bigger than 7? Are you sure? You can take off your shoes. You can count on your fingers and toes. 12 plus 7 is 19. I think you're just trying to save yourself with that one. Yeah. Anyway, 12 plus 7 is how much? Which means, is that bigger than 8? So in other words, this triangle can actually be created. It works. Okay? So anytime you have a triangle, if the three sides add, or two of the three add up to be bigger than the third, each time, then the triangle can be made. Okay? It's called the triangle sum inequality theorem. It's a whole lot of words for something that's kind of silly. Basically, it looks like this. Does, actually, I don't want to use, is 3 plus 7 greater than 8? 7 plus 8 greater than 3? Is 8 plus 3 greater than 7? Are all of those true? Yeah. They're all true. Which means, dun dun dun, you can make a triangle. I know. Okay. What about 5, 10, and 15?
So,
Is 5 plus 10 bigger than 15? No. They're the same. So that means no. So as soon as you get a no, that means
you can't make
can't make a triangle.
What if they're
No,
equal
because it's just
sides?
greater than. And it's kind of that's a good question. What's that? A ruler. Okay. Do you agree that these two are the same? Sure. Okay. Ruler. How long is a ruler?
Make sure the trench. So if I take this and I make them at, make the cut at 6 and 6. Now, again, ruler, 12 inches, right?
Okay.
6 inches for each of these, right?
Yeah.
Okay. Oh, it doesn't make a triangle because it touches.
Well, what if all three?
Well, what does it do? 4 seconds. Second. It just makes segments. So if they're equal to each other, like the 15 equals 15 part, it just lands on top of one another, it won't work. It has to be bigger than the third in order for it to make that into. It's one of those silly things that you just don't ever think of. But yeah, that's why it works. That's why it mathematics. What's that? Well, if all three are the same size, then what kind of triangle? Because why? It's going to work. Because if you think about it in terms of sixes, what's 6 plus 6? Is that bigger than 6? What's 6 plus 6? Is that bigger than 6? And then again, what's 6 plus 6? So the sum of 2 is always greater than the third. So that's why you get that. Have a negative sign. You got it? You do it? You do it?
So what happens then if you're missing a side line?
You don't have a triangle.
What are the possible values of x that you could have that creates a triangle? Think about it the exact same way we're just doing it. The sum of any two has to be greater than the third. So if you think about it, what's that? You're on the right track, but wouldn't that be the same thing, just like we did a second ago by just writing them out 3 times? Can I just write out 3 inequalities? Thanks. It was 2 and 7. I'm trying to over-exaggerate when I have that with the 7 there. Doesn't this just mean that you have 3 separate inequalities to solve for?
Yeah.
Okay. Well, when you solve inequalities, don't you just solve them the same way as you would an equal sign? The only thing you'd ever have to worry about is if you multiply or divide by a negative. That's when you have to flip the signs. But here we're just talking about adding. So what's my answer here?
1.
X is greater than 1. 15 is greater than X. Do you guys remember what it meant to say that backwards? Yeah, because remember, when you're talking about inequalities, is 2 greater than 1? If I say it backward, 1 is less than 2. I can flip them around by doing that. A lot of times what we do is we usually put the value of x first. And then on the other one, what do you get? What do you get for the other one? 7 minus 8 is 1. Negative 1. Can you have a negative segment length? No. So you throw that one out. Which means it has to be greater than 1, but smaller than 15. Remember how to write a compound inequality? X in the middle, smaller than 15, but it's bigger than 1. And that's what you write. All possible values that are bigger than 1, smaller than 15, would be able to make a triangle. Yes, because what if it was 1.5? See what I'm getting at? What's that? It's the idea that anything that's bigger than 1, as long as it's bigger than 1, it has enough there it'll create a triangle. As small of an angle it might be, it still works. Okay? There actually winds up being a pretty nice little shortcut with this stuff. Let's see if you guys can figure this out. I'll give it a second here right now. What's that? Oh no, I saw some people were finishing right now. So I want to show you this, a couple of examples here. A lot of this stuff really isn't going to be all that difficult to worry about to work with. Oops, I got ahead of myself here. Let's look at this. Something 12 and 15. What are the possible values of x that you can create a triangle with that? Again, let's write it out in terms of the algebra and see if we can find a pattern. What do you got, Miss Epps? What do you mean? Oh, you mean like greater than 1, like the number 1? Oh, I see what you're saying. Not quite. Not quite. So when you write these out, again, you wind up with 3 really fast columns. What's 15 minus 12? 3. What's 12 plus 15? And here I get x is greater than -3. Which one of those do I have to throw out? -3 again. Did you want? Oops, literally threw that one out. Did you want to restate what you were doing? Add them, subtract them. Here's your parameters. That again. All you have to do, and I will commend you on your vocabulary of explaining that with the differences and sums. That was nicely worded. How about this? Add them, subtract them.
Wow.
You find possible values. Add them for the max. Subtract them for the min. The value of x will always be in between them, and they will always use less than symbols. Okay? 3, in this example here, we would have written 3 is less than x, which is less than 27. And that would be my answer. You will always use less than symbols with these things. Add them, subtract them. Okay. So yeah, they do wind up working out really, really fast after a while. Excuse me. Thank you. I know. The weird thing that does get thrown into this from time to time is that they'll start giving you side links, but they're going to give you with dimensions. What I mean by that is that they're going to say inches or feet or things like along those lines. The worst thing that can happen is they might say it's 3 feet. But do you guys know that that means feet?
Yeah.
And then if I say, what does that mean? Okay. And then find possible values of x. Now, one of the things that I would suggest, and you may or may not remember this from some point in time with a science class or something like that, whenever you're dealing with dimensions or units of measure, and you have different units of measure. In this case, I have feet and I have inches. The easiest thing to do is always convert down. Always go to the smaller of the two units, because then you don't have to worry about dealing with decimals or fractions or anything like that. So for feet to inches, how many inches are in a foot? Well, how many feet are in a yard? 3. Shame. How many feet are in a mile? Thank you. You were off by a lot. What's that? Sure. So the things that I will ask that you guys know, because I've been known to change things up like this, you got to know how many inches are in a feet. There's 12 inches. 1 foot. 3 feet. 1 yard. 5,280 feet in 1 mile. The other thing is that I don't tend to switch things up with the metric system. I know it's just base 10, but it's easier for me to think in terms of feet, yards, and stuff like that. All I know about 100 meters, it takes about 3 seconds slower to swim 100 meters than it does 100 yards. Just in case you were wondering. It's true. Okay. What I'm saying is that because it's a longer distance, it's longer by roughly about 3 seconds. If for normal sort of purposes. So when you do stuff like this, remember the easiest thing to do. I know there's not that much going on here. Come on. Convert it to inches, which means this is 36 inches. And what gives you the parameters then? What's your x value going to be between? 16 and... It's really hard to add 20 to 36. Okay. That's what we're looking at. We did that one. Okay. Like I said, I don't have that much notes out of this unit. It's mainly just listing out different values and parts and stuff, and making sure that you read carefully. So you get to pull up the problems. Yeah, not a lot. It won't take very long at all. Yes, I know it's her birthday. Do those, please. Yeah, I didn't really have all that much with this one. And give me a sec, I'll pull up the book here and have it up. It looks like it's a lot, but it's really, really fast. Awesome stuff. Okay. Well, at least it's better than nothing. There you can at least get started then.